Okay, so let's have a look at this one here. So it says here a geometric progression has term A. Okay, so we got a geometric progression, term A, common ratio R and sum to infinity S. A second geometric progression. So the first geometric progression, you've got A, R, and you've got S, which is your sum. And you've got a second geometric progression, which is the first term is 5A, the second, your common ratio is 3R, and your sum to infinity is 10 times the first one, 10s. And the question is now asking us to find the value of the ratio between two. Okay, let's just analyze this quickly. What we have is the following. We've got basically, so the first term over here is A. So let's say the first term is A, okay? That means the next term is going to be A times R. This is now the first sequence. A times R, then it's A times R squared, then it's A times R to the power of 3, and then it continues until it gets to the nth term, which is A times R to the power of n minus 1. We also know that for this, the sum to n terms, or it says your sum to infinity, the sum to infinity is equal to S, which is equal to 1 over A over 1 minus R, A over 1 minus R. Okay, so we've got this. We can treat that as an equation, and we've got all of these terms that we can use as well. So let's call it equation number 1. Now let's look at the second geometric progression. They're saying that the first term is 5a. So the second term is going to be multiplied by a ratio. And in this case here, the ratio is 3 times the first ratio. So 3r. And then it's going to be 5a times 3r to the power of 2. And then we continue in that fashion until we get to the nth term, which is a times r to the power of n minus 1. Also, the sum to infinity is equal to 3 s's. No, 10 s's is equal to 10 times that. So therefore, 10 times that. That'll become 10a over 1 minus whatever r it is for this. And the r for this is 3r. And the a value is actually not a. Actually, the a value is actually 5a. So I'm going to change the a value into 5a. But I'm going to just double check this now. This is the sum to infinity for this one over here. The a over 1 minus r is actually s. So multiplying by this by 10, do we include the 5r and the 5a and the 3r or not? And I think we don't include it, because if I change s into whatever s is, and we know s is the sum to infinity of the first geometric progression, which is a over 1 minus r. So that means that this sum to infinity is actually 10a over 1 minus r. Okay, so that's going to be 10 times that would be this sum to infinity. Okay, now that we have this, we want to find the common ratio r that goes from each to the other. In order to find a ratio between two terms, we could use the formula that if you take the second term and you divide it by the first term, so t2 divided by t1 is going to be equal to t3 divided by t2. In this case, you'll get r. If I take this divided by that is equal to this divided by that, you'll get the common ratio, in other words. This one here will also be 3r. So looking at this, I'm thinking what we have to do is utilize the equation somehow. Let's say we want to calculate the sum to infinity of the second one, right? If I calculate the actual sum to infinity, so this sum to infinity is 10 times s, but the sum to infinity is also the formula a over 1 minus r. But in this case, that is my a value, and that is my r value. So the actual sum to infinity for this second sequence is going to be 5a over 1 minus 3r, because that's my r. And they're telling us that the sum to infinity is 10 times the first one as well, which means that we can equate those two. We can equate those two and we can solve, right? We can solve, or we can say this is equation number one and this is equation number two. But what would the sum to infinity be as well? All right. So these two are equal. So I can definitely say that I can say 5a over 1 minus 3r, which is how I would calculate the sum to infinity of this on a normal day, is the same as 10a over 1 minus r. What if I swap this around, make it a bit more simplified? 5a goes to the bottom, to become 2. The a's will cancel. Can you see if I bring this down? 10a divided by 5a is 2. And this will be 1 minus 3r. And now I'm left with r's. So now I cross multiply again. All right, so I move the 5a down, and I move the 1 minus r to the top. So I swap those two. Keeping the 10a over the 5a becomes 2, and the a's disappear. All right, now how did I do this? Remember, I'm just equating those two together in forming an equation. So 1 minus r equals 2 minus 6r. Plusing 6 on the left-hand side will become 5r. And 2 minus 1 is 1. So r is the same as 1 over 5. And that's going to be my r value, 1 over 5. So we don't know what the a value is. We can't really get that. But we answered the question. And the question asked us to find r. Okay.